Hello viewers, welcome back to my channel. Today I'm considering another topic which is under solubility, and that is hardness of water. These are the commonly asked questions in Jamb. The first question here is, the hardness of water is caused by the presence of the ions of what? Is it magnesium and silver? Is it calcium and magnesium? Is it sodium and potassium, or calcium and sodium? Please, anytime you want to answer Jamb questions or attempt any question in Jamb, you must check all the options before you choose your correct answer. Don't be excited by if you see an answer that is related to what you're looking for. Anyways, back to our question. Our answer is calcium and magnesium ions. Why is it so? Now, how do we know that water is hard? When water does not form lather with soap, when you add soap and then there are no formation of bubbles, then you know that that water is hard. Though hardness of water does not work with detergents like, there's a soapy or soapless detergent, so to say, like the commonly used liquid soap and the powdered soap. Those ones can overcome hardness of water. Or the soap I'm talking about here is the hard soap. Now, this hard soap, when you use it in water that is hard, or that's a solid soap, when you use it in water that is hard, it will not form lather with soap. That is, bubbles and foam will not come out. You will only be seeing whitish substance of which is called scum. That is what will be coming out. So what is responsible for this? That's the presence of calcium and magnesium ion. But what is a major compound present in this hard water? So we can actually say that water can be ordinary or soft. Water that is soft is free of calcium and magnesium compounds or ions. Now, why water that is hard is contain calcium and magnesium ions of tetrahydrosulfate 6, chlorides, and hydrogen triisocarbonate 4. I'm going to explain in details. Now, we have two types of hardness of water. We have the temporarily hard water and we have the permanent hard water. Now, the temporarily hard water can be removed by simply boiling it. Then, by the addition of slaked lime, which is calcium hydroxide, Ca open bracket OH bracket 2. That is calcium hydroxide. That's slaked lime. When you add slaked lime and you boil, temporarily hard water can be removed. Now, let's quickly talk about the permanently hard water. The permanently hard water can be removed by the addition of caustic alkali, that is sodium hydroxide, NaOH, and a calculated amount of washing soda, which is Na2CO3. When you add this to permanently hard water, it can be removed. You can also use ion exchange resin or permutate method. Those are the three methods for removing permanently hard water. So our answer here is B. And I'm going to quickly talk about the origin of hardness of water. How does hardness of water come to be? Now, when rain falls, you know that there is carbon dioxide in the atmosphere. Then oxygen is in the atmosphere, nitrogen is in the atmosphere, and others. Now, when rain falls, the rainwater, when it comes to contact with limestone or rocks that contains limestone, you will see that this limestone is made up of calcium triisocarbonate 4. Now, if rainwater comes to contact with it, it will not dissolve because water is not soluble in calcium triisocarbonate 4. Calcium triisocarbonate 4 is not soluble in water. But if the water contains dissolved CO2, that's carbon dioxide. Carbon dioxide is free in the atmosphere. Now, if it dissolves in the rainwater, and the rainwater now comes to contact with the limestone, then temporarily hard water will result. Let me show you the equation of reaction. CaCO3 plus rainwater dissolved in CO2. This will result into calcium hydrogen, let me write it out clearly, calcium hydrogen triisocarbonate 4. So when you see this compound, you know that the water is temporarily hard. That is, it contains calcium triisocarbonate 4. The same thing can occur in magnesium triisocarbonate 4 to give you MgHCO3 bracket 2. So these two are responsible for temporarily hard water. And one thing about this compound, the beauty of it is that they can break down easily or decompose. So let's see this. If you have calcium hydrogen triazocarbonate 4 and you eating, when you eat this compound, it breaks down easily into calcium triazocarbonate 4, water, and CO2. So that is why when you see this compound, calcium hydrogen triazocarbonate 4, it shows that it contains temporarily hard water. Or when you see the other one, which is magnesium hydrogen triazocarbonate, it contains, the water is temporarily hard. And so when you boil it, it breaks down easily into calcium triazocarbonate 4, water, and carbon dioxide. And one thing about this is that the calcium triazocarbonate 4 that is formed back is actually insoluble in water. So you can see it, you can bring it out by sieving, because it will form a solid, it will precipitate out. When you boil the water, as the water that is temporarily hard is a clear water, you won't notice anything, just water. Because this compound is soluble in water, it will be in the water, you will not know. But by the time you boil the water, even without knowing whether water is hard, just boil the water. Once you notice a whitish substance coming out of the water and it's like a paste and it's sticking to the container that you're using to boil, then it means the water is temporarily hard, and then calcium triazocarbonate 4 is being formed. Water and CO2 is also formed, which dissolves in themselves, and you get a clear water. So you can bring out this solid that is formed because it's not soluble by sieving or filtration. Now, what is now the effect of this temporarily hard water? It causes fouring of kettles and boilers, because when in industries where hot water is needed, on a large scale, if a big boiler is used, we see that if the water is temporarily hard and is being boiled, the calcium carbonate will be deposited, because this is breaking down. The calcium hydrogen triazocarbonate in the temporarily hard water is breaking down to give you calcium triazocarbonate 4, which is sticking, is like a scum, and is sticking to the container. What causes fouring, because deposit of this will become hard and it will be hard to remove or difficult to remove, and it causes fouring of kettles and boiler. It also leads to formation of stalagmites and stalactites. Now, when a cave is usually known to be hot. Now, when temporarily hard water is coming through the cave in form of rain, you know, if carbon dioxide has been dissolved in the water and it has passed through limestone, it will form temporarily hard water. That's calcium hydrogen triazocarbonate 4. When this is now falling on the cave, starting from the roof of the cave, because the cave is known to be hard, to be hot, very hot, because calcium hydrogen triazocarbonate 4 can be easily decomposed by heating, the hotness of the cave will break down the temporarily hard water, which is containing calcium hydrogen triazocarbonate 4, break it down, and then we get calcium triazocarbonate 4, water, and carbon dioxide. Now, the effect is that this calcium triazocarbonate 4 that is formed will be deposited on top of the roof, and the drops of water on the ground of the cave, rather, will also have calcium carbonate. So this will be deposited, and when this occurs for thousands of years, it leads to a pile of calcium carbonate, the one growing from on the ground towards the roof, piling up towards the roof, just like if you've seen an ant hill before in villages or in the farms. After some years, they become tall. So this pile of calcium carbonate going on the ground, moving towards the cave, is called a stalagmite, while the one that is being deposited on the roof of the cave and going towards the ground as a result of accumulation for years is stalactite. So these are the two effects of temporarily hard water, fouring of kettle, the formation of stalagmites and stalactite. Why permanently hard water actually contains gypsum. I'm going to clear the board to be able to explain this better. Now, calcium sulfate, calcium tetraoxosulfate 6, this is actually gypsum. Now, when rainwater dissolves in gypsum is not soluble in water, but when this happens, you end up getting calcium tetraoxosulfate 6. Also, another compound that is responsible for permanently hard water is magnesium tetraoxosulfate 6. We also have calcium chloride and magnesium chloride. So we can say that the presence of calcium and magnesium ions in form of chlorides and tetrasulfate 6 is responsible for the permanently hard water. And permanently hard water can be removed by the, I think I've mentioned the remover, by adding caustic soda, which is sodium hydroxide, by adding washing soda, which is Na2CO3. So I'm going to give you just one example here. I've just explained the origin of permanently hard water. So if you have calcium sulfate in water, and then we want to remove it, and then we decided to add sodium triazocarbonate to it to remove it, which is the washing soda. What happened is that this compound, you will not see it in water because calcium or tetrasulfate 6 are soluble in water. So it will be with water, it will be as clear as anything. But as soon as you add sodium triazocarbonate, which is washing soda, to it to remove the permanently hard water, you will see that something else will be formed which will precipitate out and you'll be able to remove it in form of carbonate. So when you break this down, you have calcium and so forth, 2 minus as Na plus, and CO3 2 minus. So this combines with this, they cancel out. So you have CaCO3 plus Na plus 1 combined with SO4 2 minus, exchange their valency, and then you have Na2 SO4. The one there is nothing. So you end up having calcium carbonate, which is not soluble, and then it is removed. Then this dissolves in the water. So this is what happened. This is just an example of the removal of permanent hardness of water. You can do the same for sodium hydroxide. You add sodium hydroxide to either disulfate or magnesium chloride or magnesium sulfate or calcium chloride. The same will occur. So in a nutshell, the compounds present in temporarily hard water are calcium hydrogen triazocarbonate 4 and magnesium hydrogen triazocarbonate 4, while the compound present in permanently hard water are magnesium tetrasulfate 6, calcium tetrasulfate 6, or magnesium chloride and calcium chloride. These are responsible for permanently hard water. And temporarily hard water can be removed by boiling, while permanently hard water cannot be removed by boiling. Other methods of removing temporarily hard water is adding calculated amount of slaked lime, which is calcium hydroxide, Ca open bracket OH bracket 2. Why the methods for removing permanently hard water are addition of washing soda, addition of caustic alkali, which is sodium hydroxide. Washing soda is Na2CO3, and then using the Permotit method, which is ion exchange resin. And the disadvantage and advantages of hardness of water. The advantage of hardness of water is that, or the disadvantage rather, of hardness of water is that it wastes soaps. It causes wastage of soap. It causes hardness. It causes foaming in kettles and boilers, and then formation of stagnant and stalactite. While the advantage is that the presence of calcium at times gives taste to water, a good taste to water. Watch out for my next video, which is on other topics in preparation for your JAMB. Let's quickly answer this question. The foaming of kettle is caused by the presence of what? The best answer is option D, which is temporarily hard water. When broken down, it forms calcium carbonate, which causes foaming. And the best answer is calcium and magnesium. I wish you all the best in your exam. Please don't forget to subscribe to my channel if you've not done so, and share my videos to friends. Share to those who needs it. Like my video and press the notification bell to get alerted anytime I drop new videos. Thank you.